Hey, fifth grade, this is Mrs. Kiyoko with your flipped math lesson for today, 6-4. Today's objective is to find products of whole numbers and decimals to the 10,000ths. And while we're doing that, I'm going to show you some ways you can make some drawings and models to help show your thinking. So here's our first problem. Sarah sat 4 paintings side by side in a row. Each painting was 0.36 meters wide. What is the total width of all 4 paintings? So first we're going to ask ourselves, well, what is the purpose of the question? What was it asking us to do? We're trying to find the total width of all 4 paintings. And let's find the important information. There are 4 paintings, and they are all the same width. They are all 0.36 meters wide. So I've drawn a quick model that shows that there are 4 paintings. They are all 0.36 meters wide, and if you sat them side by side, you could add up 0.36 plus 0.36 plus 0.36 plus 0.36, which is the same as 0.36 times 4. Remember, multiplication is just repeated addition. It's just adding the same number over and over, but multiplication is a little bit quicker instead of adding it all up. But this is just a one way that you can show a model of how you multiply something. Now, let's look at what an area model looks like with a different number. So I have 0.5 times 0.3, which is the same as 5/10 times 3/10. Okay, remember that way to read the number 5/10 by 3/10. That's going to become important in just a second. You're going to see why. So here I've written the problem again, 5/10 times 3/10, and I've drawn over here a lovely little hundreds chart. And so I've squared off 100 blocks there. And you'll remember that like a flat equals 100, a long equals 10, and then those little cubes that equal 1 unit. Well, this is kind of like a flat over here. So one whole flat is the same as 100 small pieces, or we could say that it is hundredths grid, okay? So each little unit in there is 1/100th. If you draw in one long, then that's the same as tenths, all right? So what I'm going to do is I'm going to show you how you can multiply using a hundredths grid. So first I have the 0.5, 5/10, which is the same as drawing 5 longs. Okay, so I have my 5 longs on there, which is the same as 5/10. And then I'm going to draw the opposite direction. I'm going to draw 3/10. Okay, so now I have my 0.5, and I'm going to be multiplying it by 0.3. So 5/10 times 3/10, and where they overlap is where the multiplication happens. So you can count the hundredths, how many little units are overlapping both the 3/10 and the 5/10. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 hundredths, remember those little units will be called hundredths. It's going to equal 15 hundredths. Okay, so that's just a different way that you can show a model. So I just wanted to show you that real quick, that there's 2 different ways that you can show models of how to do multiplication with decimals. And let's move on. So we got some problems now. We're going to actually use our regular algorithm to figure them out. You're welcome to use models if you want to, if that's helpful for you, but if it's not, if you can just use the regular algorithm, it'll probably be faster to do that. So we have 0.36 times 4. Go ahead and solve the problem, and we'll check it together in just a minute. Okay, so 0.36 times 4. Hopefully you took 0.36, put on the top, and multiply it times 4 on the bottom. It doesn't matter whether you put the decimal number on the top or the decimal number on the bottom. I usually put the number that has the smaller number of digits. So the 4 only has 1 digit, so I'm going to put it on the bottom. The 36 has, or 0.36 has 2 digits, so that's why I put it on the top, even though 4 is actually a larger number than 0.36. It's just how many digits there are, because it makes the multiplication faster. So let's multiply. 4 times 6 is 24. I'm going to add on the 2 up there. 4 times 3 is 12, plus 2 more is 14. Now I'm not done. Now I have to count how many digits are behind the decimal point. There's 1, 2, and then at the 4 there are no digits behind the decimal point, so there's 2 digits behind the decimal point, so that means that I move the decimal point 2 spaces over to the left and then pop it on. So my answer is 1.44. And yesterday we talked about the reasonableness of the answer, and I just want to double check and look at that. So I see that 4 is being multiplied or 0.36 is being multiplied 4 times, and 0.36 is less than 1. So when a number is less than 1, then I know that if I'm going to add that together 4 times, my answers might be around 1 or less than 1, but it's not going to be a big number. And our answer is 1.44. Not a very big number. Okay, so that's reasonable. Let's look at another one. 2 times 0.32. Go ahead and solve it, and then we'll check it. Okay, so 2 times 0.032, and I'm going to put 0.32 here at the top. I'm going to go ahead and get rid of that 0, because 0 that comes before the decimal point, I really don't need it. And I'm going to multiply it times 2. We're going to put that multiplication sign out to the edge, and then we're going to multiply. 2 times 2 is 4. 2 times 3 is 6. There are 2 digits behind the decimal point, so I'm going to put the decimal point 2 places over. Okay, so we get the answer 0.64. Let's try another one. 3 times 0.92. Give this one a try. All right, let's check it. Excuse me. I'm going to put 0.92 first, and then I'm going to multiply it times 3. Now before I do that, I can very quickly surmise that 0.92 is really close to 1. It's really close, 0.92, very close to 1. If I rounded it up, it would be 1. And then I can do some quick estimating. 3 times 1 is 3, so I'm guessing my answer is probably close to 3. So let's do the actual math and find out. 3 times 2 is 6. 3 times 9 is 27. I was having a brain fart. And then I count how many digits are behind the decimal point. There are 2, so I'm going to put that decimal point 2 places over, and I get the answer 2.76, which is very close to 3. If I rounded it up, if I rounded 2.76, I would round it up to the ones place. The bossy neighbor would say, hey, turn that into a 3. All right, I think there's one more. Let's try this one. 4.2 times 5.4. This time, both numbers have decimal points. So pay attention to that when you're multiplying. We'll check it. Okay, let's check it. Before we do, I'm going to do a quick estimate. So 4.2, excuse me, is very close to 4. 5.4 is closer to 5 than it is closer to 6. So I'm guessing that 4 times 5 is 20. So I'm guessing my answer is going to be close to 20. Okay, let's do the actual math and find out. 4.2 times 5.4. We do our multiplication. 4 times 2 is 8. 4 times 4 is 16. Put in a 0 because I'm moving on to the next place value. 5 times 2 is 10. Carry the 1. 5 times 4 is 20, plus 1 is 21. Add it all up. 8 plus 0 is 8. 6 plus 0 is 6. 1 plus 1 is 2. And 2 plus nothing is 2. Now I count how many digits are behind the decimal point. I have 1 right here. I have 1 right there. See that decimal point? Gotta count that one too. So 1, 2. So I'm going to move my decimal point over 1, 2 spaces. So our answer is 22.68, which is pretty close to my estimate of 20. All right. Let's try another one. 5.7 times 0.03. Okay, let's check it, see how you did. I'm going to start by estimating 5.7 is pretty close to 6. And 0.003, well, that is really, really less than 1. So I'm going to estimate that my answer is probably going to be less than 6. Okay, or whoops, I mean that's greater than 6, isn't it? I'm making this the wrong way. My bad. Okay, so my answer is probably going to be less than 6. So let's give it a try. Let me erase this real quick. And we'll give the multiplication a try. So 5.7 and then 0.03. Now I don't need to use this 0 right here before the decimal point, but I do need to keep this one because there's a digit other than 0 right there. So I can't just get rid of this 0 right here. I have to use it. So I've got 0.03, and I'm going to multiply those together. 3 times 7 is 21. 3 times 5 is 15, plus 2 more is 17. Now, I could multiply the 0, but 0 times 7 is 0, 0 times 5 is 0, and when I add it up, it's going to be adding up nothing. So I don't really need to do that, and I'm done with all the digits on the bottom, so I can figure out how much my answer is. There are 1, 2, 3 digits after the 0. So I'm going to move my my decimal point 1, 2, 3 places over. And my answer is 0.171. So a lot less than 1 is my answer. Okay, 1.171 compared to my estimate before. My estimate was that my answer would be a whole lot less than 1. And it is. Let's try another one. 22.3 times 1.2. Give this one a try. Okay, let's see how we did. 22.3, estimate that's really close to 22. Multiply it times 1.2, which is really close to 1. So my answer, I'm guessing, is probably going to be really close to 22. Let me erase that out of the way. So I'm thinking it's probably going to be close to 22. Let's double check. 22.3 times 1.2 and do my multiplying. 2 times 3 is 6. 2 times 2 is 4. And 2 times 2 is 4. I put a 0 because I'm moving on to the next place value. 1 times 3 is 3. 1 times 2 is 2. And 1 times 2 is 2. Then I add it all up. 6 plus 0 is 6. 4 plus 3 is 7. 4 plus 2 is 6. And 2 plus nothing is 2. Now I count how many decimals there are, how many digits there are behind the decimal point. There is 1, 2 digits behind a decimal point. So I move my decimal point over 2 digits. And my answer is 26.76, which is pretty close to what I said. I said 22. That's not too far off. That's only 4 off. So not bad. All right. We are finished for today. Thank you so much for hanging out with me. Have a good night. Bye-bye.